Hi everyone, today we are going to discuss about another one circuit. Here we are going to find the minimum and maximum load resistance, and we are going to discuss about the load regulations. Here we are considering the ideal Zener diode with the VZ of 5 volt and the maximum Zener current of 5 milliamps. Let us draw the circuit. Here I am considering the Zener diode and the source voltage as say 10 volt and the series resistance as a 500 ohm, and we have to find the minimum and maximum load resistance. Let us connect together. Positive supply is connected to the R1 and another terminal of the R1 connected to the load and also for the VZ. Connect the ground. And let's connect ground. Okay. And we will define the Zener diode. Dot model D resistor is on is equal to 0 ohm, and when it is off is equal to 1 meg, and voltage forward is equal to 0, voltage reverse is equal to Zener breakdown voltage VZ is equal to 5 volt, and the IZM maximum breakdown current is equal to 5 milliamps. Let us calculate one by one. In previous video we have discussed how to confirm the Zener diode is in breakdown region. Now we will find the minimum load resistance value. We know that for the minimum resistance value, RL minimum is equal to RS into VZ divided by VS minus VZ. Please comment if you need to discuss about this formula abbreviation. So let us apply the value. RS is equal to 500 ohm into 5 volt, VZ as a 5 volt divided by 10 volt minus 5 volt. And when we simplify this, we are getting 500 ohm. So RL minimum is 500 ohm. And next we are going to find the maximum load resistance. For this we need to apply the KCL at the node A. This is the node A. So as per KCL, IS is equal to IZ plus IL. Okay. See here, IS is the series resistance and the IZ is the Zener current and the IL is the load current. When the resistor is maximum, the current flowing through that resistor is minimum. Okay. As per that, if IL is minimum and the R max, RL is the maximum, and the RL is maximum, okay, the maximum current flowing through the IZ. IZ also maximum. Okay. So we can conclude maximum current through the IZ as a IZM, which is equal to 5 milliamps. Okay. And the Zener breakdown voltage Vz is equal to 5 volt. Okay. If you rearrange the term at the node A, IL is equal to IS minus IZ. Okay. So here we need to find the current across the series resistance, so that IS is equal to Vs and also Vz. Zener breakdown voltage also fixed. Okay, Vz divided by Rs, which is equal to 10 minus 5 volt divided by 500 ohm. Okay, when we simplify this, we are getting 10 milliamps. Okay. So we will apply this value. Here it is IL is, now we are going to find IL minimum is equal to IS minus, when it is IL is minimum, IZ become IZM. Okay, we will apply the value now. IS is 10 milliamps minus 5 milliamps. Okay, which is equal to 5 milliamps. Okay, we know that maximum IZM is the 5 milliamps. Okay, and from this we will calculate the maximum resistance value. So RL max is equal to Vz, Zener voltage. The voltage is this node, divided by IL minimum, because when it is IL minimum, R becomes R max. Okay, so that 5 volt divided by 5 milliamps, which is equal to 1 kilo ohm. Okay, from this we can conclude that if the load resistance lies between 500 ohm to 1 kilo ohm, Zener diode properly act as a voltage regulator. Let us verify through the simulator. I will apply the minimum resistance value first. I am going to run the simulation. Okay. See, initially I am going to check the current across the series resistance, which is equal to 10 milliamps. Okay, and also we can find voltage across the load, which is equal to 5 volt, 4.999, 5 volt. Okay, and if I change the value 1.1 kilo ohm, okay, I'm going to change maximum resistance value as a 1 kilo ohm. So that I'm going to run this. Here also I'm getting 5 volt, proper regulation I'm getting, and I am changing to minimum resistance as a, instead of 500 I am considering 450 ohm. So when I run this, the output voltage become, instead of 5 volt we are getting 4.73. So 0.3 volt got dropped. If I consider, instead of 1 kilo ohm I am considering the 1.2 kilo ohm. I am running once again and I am calculating the current across the Zener diode. Okay. So now I am getting the 5.8 milliamps instead of 5 amps. We know that we have a maximum Zener current as 5 milliamps. If current is more than the actual value, the diode will get damaged. So from this we can conclude that the load resistance we have to consider from the 500 ohms to 1 kilo ohm. If it is more than or below than that, though we are not getting proper regulation from the Zener diode. I hope that you are able to understand this circuit. Thank you for the watching.